Hey guys, sorry I couldn't be there today because of the load shedding. Horrible. I know I haven't experienced it yet, so this is the plan. I'm going to shoot videos every time it happens, and you're going to watch them at the same time that you would have had the lesson. Okay, so first step in today's lesson is to open up the collaborative document on the shared drive. It's in semester 2 folder, and then in module 1, and then just download it and upload it to your own drive. I think you actually have to make a copy of it. You know the whole process. Answer the questions and then watch the video from this point onwards. So pause it now if you haven't answered the questions from the collaborative document. Answer them and then carry on watching this video. I am going to instruct you to pause the video and answer a few warm-up questions. Please do pause it and please do try and answer the question. Cool. Let's get straight into it. So unfortunately with the software I use to record myself, I can't go full screen, so I'm really sorry about that one. Okay, so here's Clem the chemist again giving us some top tips. Learn how the alkali metals react with water. This is super important. We have the any alkali metal, so let's take sodium for example, plus H2O, so that is the reaction with water. It's going to form a hydroxide metal. So for the sodium plus water will give us sodium hydroxide and hydrogen. Okay, and you can do that for all the other ones as well. So calcium, francium, lithium, potassium, any of those, it always forms a hydroxide with water. But if the metal is just with oxygen, so it's just reacting with air, the oxygen in the air, then it forms a metal oxide. So for example, sodium plus oxygen gives me sodium oxide. Okay. Know the properties of alkali metals. They're soft, their melting points and boiling points decrease as you go down the group, the reactivity increases as you go down the group. There's a few other properties there, I can't quite remember them now. When it reacts with air, it goes from being shiny to dull. A few other ones that you can go and remember. How to write equations for reactions with air and water. I've just gone through that. So those are the top tips for the alkali metals topic, which is module 1. All right, here are the warm-up questions. Pause the video, read this question, give me an answer, and then unpause it to get the answer. Okay, the answer to this question is changes from shiny to dull. All right, next question, pause the video now. All right, so when lithium is added to cold water and bigger hydrogen forms, state the test for the hydrogen. This is where you light a splint or a candle or whatever you want, and you collect hydrogen, and you put the little flame at the end of the test tube, and you should get a popping sound. So the answer to this is use a burning splint. There's some errors with the wording here, to see if it makes a pop. I'm just going to quickly go to a YouTube video of this. So here's hydrogen. Watch the pop. Ready?
You did it.
Ciao. Perfect. Okay, so that's the little popping test. If it makes a pop, you know it's hydrogen. Next question. When lithium is added to cold water in a beaker, hydrogen forms. A few drops of universal indicator added to the solution. Explain why. Pause the video. And the reason for this is that because of that metal hydroxide. So those hydroxide ions that will dissociate from the metal when in solution, those give a alkali color, which is blue with the universal indicator. And we actually just generally know that hydroxides like sodium hydroxide, potassium hydroxide, we know that these are strong bases. Okay, so it's general knowledge, but also you can do a test for this. All right, the breakout room, we would have gone into our breakout groups, we would have done the collaborative document, and then we would go through the answers. So I'm going to go through the answers now. If you haven't done those answers, do them now, please. Okay, first answer. I'm going to go through this super quickly. Answers in red. All right, next one. Wait, we can go through that one there. There you go. Next one, chemical equation. There you can see the calcium hydroxide and the hydrogen gas. Next one, electron configuration. We did this question yesterday. And the answer again is because it's easier to lose that electron, that outer electron, or that valence electron. And that's because it's further away from the nucleus, so there's less of an attraction between the nucleus and that electron. Pretty simple. That's it. Awesome, guys. Sorry again that I couldn't be there, but I think this will be super helpful. And if you've got any questions for your assignment, drop them in the discussion forum under Module 1 assignment questions. Have a beautiful day, and I'll see you next week.